Hello, Herman here with a new video in the ClearPass workshop series where we built the ClearPass deployment from scratch and integrate with wired, wireless, Active Directory and much more. In our previous video we enabled profiling, so we configured on our core switch the IP helpers to get DHCP requests forwarded to the ClearPass server, which allows the ClearPass to learn about the device that are on the network. So we can see our Windows 10 computer, our AP, and in the meantime we found there is another AP205 as well on the network. So that's all great. However, every now and then I hear people that can't make profiling work, and in most cases the reason is that the DHCP packet is not reaching the ClearPass. So either there's a firewall in between or there's a misconfiguration on the switch. It can be many reasons, but in order to prove that it's not the ClearPass server, it's good that we can do a packet capture. And a good thing is that while hidden, there is a built-in packet capturing feature in ClearPass. And in order to do a packet capture, we need to go under Administration, Server Manager, Server Configuration, and there we can select our server. Then we select Collect Logs. So you can see by default is collecting a lot of logs, and there is an option to capture network packets. So let's deselect all the logs. These are not for use at this time, and we enable the packet capture for a duration of 60 seconds. And under advanced options you can do even packet filtering. Now a lab system, I don't need to do any filtering, but on a busy system that absolutely makes sense to filter your traffic. Then we need to add a password to protect the zip file that can be downloaded later on. Now it will start capturing, and now it's running for 60 seconds. So I go to the other session that I have, and here under the access tracker, what I will now do, I will do a port bounce on the authenticated Windows 10 client. So that will bring down the network port, and after that the client will do a re-authentication. So in the packet capture we should see the change of authorization, we should see the radius accounting, the new radius request, and after that the DHCP from the IP helper. So this is a good example of how the traffic should look. And if you know how the traffic should look with troubleshooting, you can also see when it doesn't look good. I should have a re-authentication by now. I think that's the, yeah, that is the re-authentication. So let's switch back to our packet capture. And we can see that we can click to stop it, but we already passed the 60 seconds. So the capture is complete. We can download the file now. You can see it's a zip file. This zip file is password protected with the password that we had before. And from Explorer, I use 7-zip to open the file because there is a tar.gz file within the zip file. So first extract the zip file, put in our password. So now we have the tar file, and we can see there is a folder structure with packet capture in there. And in that folder we have a packetdump.cap. This is a file that you can open with Wireshark. So let's extract that to the downloads folder. And there we have the folder. Now we just double click because we have Wireshark installed. It will open it in Wireshark. You can see there's a lot of traffic, also internal traffic. Let's filter that out. So I have a filter prepared here. If the UDP port is 67, which is DHCP, or 1812, which is radius, 1813 is radius accounting, or 3799 is the change of authorization traffic, we can filter out just that traffic. And there we can see that first we see an COA request coming from the virtual IP of the ClearPass server, going to the switch, and it's acknowledged by the switch, so everything is good there. Also in the packet you can see the username being disconnected and the MAC address being disconnected as well. Then immediately after that, because the session is terminated, we see an accounting request which contains the radius stop information. Then we see roughly 15 seconds pass, so that's the time that the port has been down. And after that we see an access request. So this is the .1x deep authentication from the client. You can see there is information going between the switch and the client and the ClearPass. And in the end we see an access accept. And the access accept, we can expand the radius protocol, and there we can see the first attribute. We can further expand that, and we can see that is the Aruba user role. So with the value contractor. As well, we can see the username, so the Radius IETF username that we are returning. So you can just see in the traffic the information. Then immediately after that we see a radius accounting start. Then we see the DHCP request. So if you have a failure with the switch configuration or firewalls in between, you will not see that, and then Profiler will not work. So this is good. And then a few seconds later we can see the accounting, and in that accounting packet we can see the framed IP address. So the switch has learned the IP address through the IP visibility and is then doing an accounting request to update ClearPass with the client's IP address, then 113.100. So this is how it should look. So that also helps you to understand if it doesn't work, then you know where to have a look. So in this video, we did a packet capture through the collect logs feature of ClearPass, and this allows us to do troubleshooting if things don't work, or if you just want to understand how it does work. So we went through the packet capture, and I hope that is useful for you to better understand the communication between the switch and the ClearPass server. If you like this video, please press the like button. Also, put your comments below the video, and don't forget to subscribe to our channel. Thanks a lot for watching.